Today we're going to do lesson 5, which is solving for any variable. This is called literal equations, okay? And this is on page 10 of your packet. So let's talk about the steps first. We're going to kind of work on the right side. The right side first before we go to the left side. So the first step is to highlight or circle the variable you need to isolate or get alone. So in literal equations, ignore what I wrote here for right now. Just ignore that. But if we look here on our first one, if we just look here, it tells you to solve for y, right? So we're going to highlight y in this equation. So I'm going to highlight that y because I know that's what I want to get alone. Okay, so that's the one I want to isolate. Number 2, use inverse operations to cancel variables on one side of the equation and move them to the other side. Remember, inverse operations are multiplication and division. It's just the opposite of one another. And then addition and subtraction. Those are inverse operations. Okay, so to undo from one side to the other, we're going to use those inverse operations. So I'm going to move on. So obviously pause the video if you need to write this down because you probably did not write it that quickly. I wouldn't be able to. So here's the directions. Use inverse operations to isolate a given variable. So we have to get a variable alone. So I told you to highlight or circle the one that it's asking to get alone. Let me highlight that a little bit better. So make it a little smaller. I'm going to get this y alone. Okay, that's what we're trying to get by itself. Now I wrote the equation in red over here because I want to show you, notice this is exactly the same as this, but the only thing I did was I substituted the 2x for just a number. I just picked a random number. I put 10. So 10 plus 3y equals 6. Notice how those parts are the same. And here I'm trying to solve for y. So I just got something that you guys are used to. And let me try to solve this one first. So the first step here would be to subtract 10, right? From both sides. Because we're trying to get y alone. So 3y equals 6 minus 10 is negative 4. Right? And then our last step, we use inverse operations. So we divide by 3 because it's 3 times y. So we're going to divide by 3. And we have y equals, and obviously that doesn't go into one another. So it's just negative 4/3. Remember, I made this up. But I just wanted to remind you how to solve an equation because we're going to do the same thing here. So if we need to get y alone, just like here, how we subtracted 10 because we need this 3y alone, well, I'm going to subtract 2x. Because I need that 3y alone because I'm trying to solve for y here. So I'm going to subtract 2x. Well, what's 2x minus 2x? Did we move it to the other side? Yeah, because 2x's minus 2x's is 0x. You're left with nothing. So that cancels out. And we have 3y equals. Now, I'm just going to put this in proper form. And the proper way to write this is to put the x first. So I'm going to put negative 2x. And then I'm going to put plus 6. So see how I put, this is the same thing as this, right? I just put the x first, and I put negative 2x plus 6 instead of 6 minus 2x. Now, again, we're still trying to get this y alone. We're trying to get that y by itself. Well, what's the very last step? My very last step, just like we did over here, was divide by 3. So I'm going to divide by 3 on the left-hand side. Whatever I do to one side, I do to the other. That cancels out. Now, instead of writing this as y equals negative 2x plus 6 over 3, I'm going to split these up into 2 pieces. So, because remember that whole thing is being divided by 3. So, I'm going to split this up into negative 2x over 3 first. So, I'm going to do negative 2x over 3. And then I'm going to do plus 6 over 3. Now, why can I do that? Because remember, can't we combine the top if the denominators are the same? Can't we combine the top? So I could rewrite this as this, right? I could say negative 2x plus 6 over 3. I could combine them into one fraction as long as the denominators are the same. But I'm going to split them up. And then I'm going to simplify this because what's 6 divided by 3? 6 divided by 3 is 2. So my final answer, let me write this in a different color. My final answer is y equals negative 2 over 3x, or negative 2x over 3, which is the same thing, plus 2. So that's my final answer there. Okay. So look at this one. xy plus c equals w for x. So I'm going to highlight my x because that's what I'm trying to get alone. Now here's the key here. Remember up here how the first step that we did was we moved so we were trying to get y alone, right? So the first thing I did is I moved the other term to the other side because I need the 3y by itself. In the same way, we're solving for x here. That means I need to get this whole term by itself before I can get x alone, right? So you always do something to the term that doesn't have the x in it. Just like here, I did something to the term that didn't have the y in it. So I'm going to subtract 2x here first to both sides, and then I'll worry about the 3y. Well, here I'm going to subtract c from both sides, and then I'll worry about the xy because we're trying to get x alone in this case. Okay? So always subtract or add whatever doesn't have the variable that you're solving for. So I'm going to have xy now left on this side equals w minus c. Now it doesn't matter when you have a w and a c. When you have, you could have put negative c plus w. It doesn't matter how you write that. Okay, now again, I'm going to highlight my x, and then I think, okay, well, what is my x and my y doing? They're multiplying. So in order to get rid of multiplication, I'm going to divide by y. That cancels because y divided by y is just 1, and I have x alone now, which is what I wanted. And I'm going to split this up again. I'm going to say w over y minus c over y. And you can split it up or you can leave it. You always split it up when there's a number involved, okay? But I'm just going to split it up to keep it the same as I've been doing, okay? All right. Now here we're solving for y. This one's definitely more difficult, okay? So, because look, y's on the denominator here. But let's think, okay, so remember how I said we don't touch this till the end, so I'm not going to touch that one. I'm going to move the w to this side. So I'm going to subtract w. Because we always want to get alone our term with the variable that we're looking for, that we're solving for. So x minus w equals c over y. Okay, so now here we go. We're still solving for y. So here, I want to multiply each side. Think about this. Think about when let's say we had x minus, 2 equals c over 4. I don't know. Something like this. And we wanted to get the c alone. The first step, you know what? I'm not going to do that example. Let me do something you know. Okay, let's do, let's see. Let's do 3 equals x over 2. Okay, let's do this. And pretend we're solving for x, okay? How would we get x alone on the top? Well, we'd have to multiply by the denominator, right? I'm going to multiply each side by 2. So these 2's cancel out, and I have x equals 3 times 2 is 6, right? So in order to get this fraction away, I have to multiply by the reciprocal. Technically, I multiplied by 2 over 1, right? And then that cancels out. Okay, in the same way, to get rid of that y, I'm going to multiply by y over 1. You can think of it like that. Okay, so I'm going to multiply this by y over 1. Now, again, I'm trying to get y alone, so I know I'm kind of doing the opposite here, but I need to get rid of this y on the denominator. We always need to get rid of our denominator before we can touch the numerator. So look what happens here. That cancels, right? Okay, so now y over 1 over here is just the same thing as y. Anything divided by 1 is just itself. So y times x minus w equals c. Okay, so again, I'm going to highlight what I'm trying to get alone because it's not alone yet. Now I just moved it to the other side. Now here's the key. Do not distribute because we're trying to get that y alone. So here's what we're going to do. Isn't this y times x minus w? What's the opposite of times? Division. So I'm going to divide each side by x minus w, this whole thing. I'm going to divide each side by x minus w. Now we don't have to take the parentheses. I just want to show you we're canceling this whole thing out and we're going to have y equals c over x minus w. Now we can't split this up. Don't do c over x minus c over w because this time, if it was x minus w over c, that's when we can do x over c minus w over c, because they have the same denominator, right? This whole denominator comes as 1 when it's a subtraction sign in the middle, so that's your final answer. Okay, I'm going to do one on the practice with you, but I'm going to do a different video because it's the other direction. So I have to, maybe I'll just write it actually. I'll just write it. Let's do something like, number 5, negative 3x plus 2c equals negative 3. Negative 3x plus 2c equals negative 3. And we're solving for x here. So I'm doing number 5 on the homework for x, because I just want to keep practicing one more of these. So I'm solving for this, right? So I know, remember what I told you was we're going to leave this on this side and we're going to move the 2c to the other side. So I'm going to subtract 2c. 2c minus 2c is 0. So I have negative 3x equals negative 3 minus 2c. You could also put negative 2c minus 3. I'm going to highlight my x again because that's what I'm trying to get alone. Now, this is multiplication, negative 3 times x, so I'm going to divide by negative 3 to each side. So we have x equals negative 3 minus 2c. Now, remember how I told you to split this up? If it's just one number on the bottom, like a negative 3, we split it up. Here there was 2 numbers on the bottom, or 2 letters in this case, so we don't split it up. But when there's only one letter or one number on the bottom, we split it up. Okay, so I'm going to split this up. I'm going to do negative 3 over negative 3. And then I'm going to do negative 2c over negative 3. And then I'm going to simplify, because I can simplify now. Well, negative 3 divided by negative 3 is a positive 1. And a negative over a negative here is a positive. So instead of a negative 2 over negative 3, I'm going to put plus 2 over 3c. And that would be my final answer.